Now let's see how to find the position vector of a midpoint of the line segment joining P and Q. So that's P and Q, right? And I'm talking about the point R, which is the midpoint of P and Q. And I'm looking to find out the position vector of this point, basically. And I call it to be vector R, basically, right? Nothing much. Now, I can write the position vector of P as, let's say, I take it as vector A, and the position vector of Q as, let's say, I take it as vector B. And since we're talking about vectors, that's how it goes. Now, we know from section formula, vector R for M and N not equal. Now, in this case, M and N are equal. Why? Because R is the midpoint. This ratio should be equal. So here, M is equal to N. That's it, guys. Otherwise, in general, section formula, M and N are different. That's what we actually learned from the previous video. Now, if that is the case, what happens to M and N? They are equal. So instead of N, I'll replace it by M itself. So MB plus MA, all right? Because I know that M and N are equal, instead of N, I'm writing M. That's not much. So it goes M plus M, because what's happening, I can take M common out, I'll get vector B plus vector A, and you have M plus M is 2M. Now I know one thing, that vector addition is commutative. Vector B plus vector A is nothing but vector A plus vector B. I can write this time as vector A plus B, okay, and divided by 2 times M. M goes off to give you vector A plus vector B divided by 2, and that should be the position vector of the midpoint of the point, basically, which is the midpoint. That's what I'm looking for. Position vector of this guy, which is nothing but a point which is in between P and Q. That's all, guys. So I can write this guy, that is R here, as nothing but this vector, that is vector A, and this vector, which is vector B. I add them and divide it by 2. Nothing much. Pretty easy.